So yeah, all right, folks. Can I start now?
So we'll start in 10 minutes.
Yeah, yeah, fine,
Yeah.
fine. It's what? Okay, okay, fine, fine. Yeah, fine, 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 fine. Yeah, folks. I'll just start off the session. You just keep allowing the people who just enter because I don't want to waste others' time also, and I don't want waste to waste your time also. So just let's just start it off, okay? So hi guys, I'm Vishwas Narayan. I'm an intern as an SD intern in Alpha Software Solutions. I basically research on swarm intelligence, and recently I just shift myself back to this field called as bioinformatics. Is my audio and video clear? How
Yes, it is
the
clear.
Yeah, thank you so much. Thank you so much, Pavan. So now let me just start with a basic intro on what stem cells is all about. Basically, I got influenced by an lecturer called as Onur Mutlu, who is an emeritus professor in the Carnegie Mellon University. And basically, he just taught me one thing, that it's not the subject, it's not the matter which you are really dealing with. It's just about the problem statement. How do you solve it, and how do you make sure that your problem statement doesn't make an hell out of a problem, because you are bound to solve many problems at one given point of time. Not just that, let me just present my screen. Is my screen visible to you guys?
Yes, it is visible.
Yeah, thank you so much, Pawan, for I think you're the moderator here. Thank you so much. And I'll switch off my video because I don't want the presentation to be affected by the bandwidth which the video might use. So I'll switch off my video now. So let's just start with the stem cells and the other techniques. Why I'm saying you that you are basically not just doing anything for the sake of science or ML or DL. You're basically working hard in order to get a proper optimized biological solution in which ML is being embedded into. So now let me just give you a quick disclaimer with the sign. You are not just doing anything based on completely an ML algorithm or completely a bioinformatics part of it. You are basically embedding two fields, and you're not saying that you are very thorough with the biological matter which you are considering, or else you are very thorough with the ML matter. Basic thing is you have to be clear about what your purpose is and how your algorithm needs to be taken care when you have such kind of critical data. So now I'll show one more PPT which will just have to bear with me, because I first need to say what's the pros and cons of having the stem cells in mind. Everybody knows that stem cells is just a form of a blood which just flows in, and all these kind of cells get done, and it's pluripotency and all these kind of matter. Because I assume that you neither have any sort of a knowledge prior to this session, and I'll give you this session now. So now, why I'm saying you, this man is one of the most ferociously patient and yet a most diverse personality which I ever saw and which I ever experienced personally, because he has a 7-inch scar which just healed off. And probably if I had the same scar, I would be saying, okay, I'm looking just ugly. But now this man has really faced the battle of his life and he has come up, even though faced the real battle in his life. Now he just gave that regenerative medicine which says that he just had a scar which is 7 inches and now it's vanished and he can be as a normal human. How it's possible? It's all because of the stem cell which actually worked in repairing that tissue. In order to do that work, you are supposed to be giving out yourself a little bit of will and yet a little bit of stem cells in order to give that. Why? Because not a magic pill, but an MSc. Not an MSc, Master of Science or anything. It's mesenchymal stem cell. Because when I looked at Bernick cycle and he just said it once upon, I performed wound care or minor surgeries. I would always apologize for any pain I was causing the animal and they would lick my hand. It's just because he was an very well-known scientist and also a doctor. He just said that, me out of anger due to the pain, they also are more forgiving than the people and more and are for human beings and other animals. That means even though you are having such a good amount of pain, which actually is supposed to be killing you, you just have that because you are emotionally connected and your stem cells are making some sort of a change. If I told a patient to raise the blood level to an immune globulin or kills, this is also from Bernard Siegel, which he says how tender love and care will basically affect you in just giving yourself a new life. If any one of your family members has something like Parkinson's or something, it's just tender love and care which just cures them in a day. In a fraction of a second, they can be really done. Why? I'll say you in the future slides because how not just medicines which just worked on people, it's the emotion which just worked on people, based on which stem cell therapy is also embedded. I'm not joking. The amount of emotions which you have will be affecting your stem cell growth. I'll be covering this in the future slides. Life is a lifelong labor and it's just pain that you give birth to yourself. That's also from Bernard cycle. Where I am not saying just emotions just work here. There has to be something called as signaling molecules. These are chemical signals which just raises up and forth, back and forth an action of just to produce the good amount of stem cells which you require in order to heal your pain. It's not about being just physically strong, mentally strong. To just give you a clarification, all of us have a little percentage of fat in our body. We actually say that it's not doing anything to my body, it might be killing me. No. Your adipose tissue is one such tissue which is capable of producing its own stem cells. So now if you're fat, don't worry that you're fat. Just burn off the fat. Just make sure that you enjoy the process of burning the fat and also make sure that your health actually becomes fasterly recovered. That means your fat can be your healing process. The way you burn it, it's going to just change your variation in which you're breathing today or which you're living today. But your fat is required. Even the bodybuilders or any person who just thinks that I just want to get rid of this fat, they just do that. When your mesenchymal stem cells are being signaled as if there is a wound in an epidermis, dermis, or any layer of your skin, you're basically doing not just a signaling, but you're basically preparing yourself to create an antibody in which it can fight against that injury or even an ailment or even a disease. It's not about being just one guy who just walks up and just makes sure that everything gets in. Stem cells are there everywhere. Your liver produces stem cell, your heart produces stem cell. Just imagine if you're of the same size, if your heart was in the same size from the day you're born to the day you're dead. That makes no sense because your heart needs to keep pumping a good amount of blood in and out of your in and out of the heart in order to keep the nutrients moving inside your cells, and also for giving that circulation, or else your body will cease to work and you are dead. So now your blood vessels have this medical signals which just gives out an impulse which says that yes, there is an injury, yes, I have to heal this wound. So now, yeah, hello, anybody? Anybody talk to me now? I didn't get it actually. Okay, sorry. It's just a
You're
distraction.
audible.
Yeah? Okay, fine. Okay, let me just continue with my talk now.
Yes.
Okay, let me just continue my talk. So now your pericytes are just one such stem cell receptors which actually affects the way in which the stem cells are supposed to be performing in order to give that heal for any wound or any ailment in the body. It need not have to be anything much more sophisticated that yes, only a specific kind of a stem cell has to go in. No, because your stem cells are pluripotent. Let me just say one thing. Let me just say this as an stem cell which is just being produced freshly in your body, and now you just go to a genomics lab and you just say that okay, it's not working out proper to me. It's not you which is affecting it, it's the previous information which the stem cell had collected. So progenitors are one which will be affecting in the future to which cell this stem cell need to be. So now with the previous information, with the new information it has the tendency to become the new cell. That means just imagine a baby, a fused egg and a sperm giving out a new baby which has all heart, liver, brain, and everything just from few cells. And this is where you call as pluripotency, where one cell can regenerate itself, divide itself, and make its own type. So now, progenitor cells are just basically one such receptors where you don't really require to just have an chemical impulse also, because your body requires something to heat every given point of time. There are 120 million red blood cells which are dying every day in your body, actually an hour, which is just getting regenerated at every given point of time. So now the dead cell plus the stem cells will be giving you a new blood cell, which RBC, the red blood cells, in order to keep your life moving. So now vascular cells are basically one such things which build the heart. These are not just one aspect which you just need to cover when it comes to stem cells. It can be multiple, because when you look at pluripotency, you can generate a cardiac cell, you can produce a liver cell, you can produce a kidney, you can produce an heart if you want, because 3D printing of the organs are in much more bloom now. So now you biotech guys, you need to really work on the transaction factors and all these kind of techniques in order to give you a little bit of push in order to just produce those cells and fabricate it in the future. Now, why I'm saying you this, in future, I'll be referring to somebody called as Candace B. Perth, who will be working in order to give you an effect of opioid receptors, which are there not just in the vessels of your blood or the arteries of your blood or in the heart, but she also found out that it was also present in your muscles. That's where she also was supposed to get a Nobel Prize, but she didn't get a Nobel Prize because her Nobel Prize was being forced by somebody, her own guide. So now be careful with such kind of aspects also, because in future you are bound to have them. So parasite section. It's just a simple matter of fact that your blood cells are getting destroyed at every given point of time. So now at the end of the day, you are not just bound to do anything which you really want to do. You're just in one place where your body is just healing now. So now what these cells do is, there are medical receptors which just get inside your body and they start searching where is the wound, or where is the ailment being caused. And now, these pericyte sections are where the stem cells tend to act in a very active fashion. This is just a brief intro. Don't worry. I'll be giving you the slides, everything. This is actually my second talk here on, not here, using the same slides. It's also in my featured section in the LinkedIn. I'll post the LinkedIn profile and everything in the end. So now, I just made this meme. Sorry for making this meme because when I look at something called as a vascular cells and a receptor cell, your stem cell have nothing to do in your life. At the end of the day, whether these have major function or these have major function, but this man has a real importance here. So that's why this guy, the stem cell, will always be carrying every information which he just picks up. It can be produced from your broken bones, it can be produced from your torn muscles, or it can be even produced from your damaged tissues. It can be anything. It can be anything. But your stem cells are made to have the bounded history and are made to produce. This is also where your lymphatic cells comes into the picture. This instrument might not be of any use to you today now, but at the end of the day, everything is being affected, but your lymphatic system will be just this one chisel of lowest frequency which will be affecting in a very big fashion. They might be shouting at the end of the day, but without this, nothing works. Your lymphatic cells are those which actually builds out the section of the blood cells in which you will be intending to push the parts of the nutrition and the oxygen levels into the body where the blood can't reach. At the end of the day, I would love to give you this podcast, which is from one of my favorite scientists, Christina Comella, who is the best known stem cell scientist in the world today. This is actually not the actual podcast, which I really want you to see. This is the one. A bodybuilder making an episode of podcast with her. And also, these are some of the techniques where I'll just give you one such information. This guy's name is Norman Cousins. He actually had one thing in his life that he just wants to cure himself from the frozen hands and the legs. Now, by the way in which his friends were affecting him through the talk, through the emotions, he just got recovered. That's where he wrote this book called as Anatomy of Illness. It's an 80 pages book. Please do read it. It's an amazing book. And don't be shattered after reading it because you have been taking stem cells and all these things for no time. And now I'll come to one more thing. Your stem cells therapy has this teratoma has one such problems in which you're bound to not to have anything in life. That means you're just affecting yourself at one given point of time by saying that, okay, let me just take the risk of actually doing this. This is one baby which actually had this teratoma issue when it was born, and now it's an incurable disease because once the stem cell gets in, it can't be taken out. So now let me just give you a brief intro on what your part as a data scientist will be. I'll be presenting this slide now. And when you look at a stem cell like this, every time when you have something as a transaction factor, there is a pioneer. Hello? Hello? I'll be presenting now. So
Guys, technical issue. We will back in 2 minutes.
Okay, sorry folks, I was in the middle of the hush and I really do not do much now. Sorry for it. Or if sorry for it. And I don't know what's actually happening here because I'm in a I'm in a place where there is no network available now. Yeah, hello Jayashree, I'm in the session now. I'm in the session. I'm in the session. Yeah, fine. Now I'll just start off it because I really knew that where did I actually stop, guys? Do you remember the slides now? At least from here, right, guys?
Your screen is not visible. I think screen sharing is
I shared the screen now, right?
visible, visible.
Yeah, I think I shared the screen now. I think this was the last slide which I was presenting, right? Or is this one or this one? Guys, at least respond because in the virtual world we can't really get to know anything. Sorry for my bad. It's my bad actually because I get involved too much in the work and I actually don't get it. Anybody respond whether I stopped from here or there?
Before that, a boy's eyes was there, no? In that slide. Yes, before this. Before this.
Before this?
Yes, before. Before. Boy's eyes was there. In that eyeball was enlarged.
Okay, this one.
Yes, yes. Yes.
Okay. Thank you so much. It's Aman Singh. Thank you so much, bro.
Welcome.
Don't worry, I'm also a student. You can call me bro. I don't require the sir and all these things. And I would just say one thing. Please do, when I say share this slide, please do watch this session. Please do watch this TED Talk because the amount of passion which she has put in order to give the stem cell research, it's an humongous one because I really felt very emotional, and she also gets emotional in this talk. And let me just give you one more thing. You have to applaud yourself, because you are working in a field which actually is going to change the phase in which medical industry is going to change. So now I'll start sharing from here. No, I'll start sharing from this slide. No, I'll just go to this. So let me just come to one of the problem statement. Is my slides visible? The screen share visible? Anybody please do respond.
Yes, it is visible.
Thank you so much. So I'll be giving you a brief intro on what we did. Because let me just say one thing. How many of you think that uh, everything was done with electronics when it comes to this person who had this ALS syndrome? It's completely wrong. Because I'll say you the reason. Everything for his movement of the chair was being controlled through his eyes. Because stem cells in your eyes are much more potential to those kind of ailments and the kind of losses which these organs might take. Your neurons in your eyes doesn't lose the control, because the stem cells are so potent in order to reduce that impact also. Thus, if he was walking, not walking, if he was even moving his chair or anything which he was being seated upon, it's through his eyes, but no part of his body being working. This is his last speech. Please do look at it. And this is also a TED talk which he says what focus is not about. We say studying is genetics. Our parents complain that you didn't do well, and you're just carrying the genes of your parents. It's completely wrong. What you are today or what you are tomorrow is never decided by your genetic information. What you are as a human being, an Homo sapien, is being decided by your gene, but not the things which actually your parents say every day. If you score less, score less. Don't worry. You are supposed to be something else apart from it. A very famous psychologist says, Eric H. Erickson, you can really get to know what this psychologist was all about. He really told that our children are not born to study what is being taught. Our children are supposed to be inventing things. That's what he said. And if your parent says that you are not supposed to be studying this or that, you just have to study what's there in your syllabus, just say to them, I am just born to be something else. It's not your genetic information. It's not me or it's not you. I'll decide what I really want to be at the present of time. And this guy is a famous bodybuilder who really gave him big breakdown when he just only works out for two days a week, but yet he's a competitive bodybuilder. It's because his stem cells are much more genius than what his body is. That's why bodybuilders tend to go with the genetics and genomics and all these. It's a big science. Don't worry. Even if you are not getting job anywhere or anywhere else, a bodybuilder is waiting for you to be a genomic scientist with him. So now this is one such talk which will be saying how only books are basically affecting what you are and what your gene could not do. So this is the TED talk. Just do watch it. And also cloning is one such technique in which we are actually fond of. Genomics, proteinomics, your genetic engineering and everything is coming into picture because there is a lot of involvement. So now getting to know what this cell might intend to be through this artificial activation is actually being simulated in a cloud cluster. It's not GCP or anything. Universities have their own high performance computing instance. IISc has one high performance computing instance in which they'll be working. So now my case study was on Alzheimer's disease. Not Alzheimer is a dementia, but all dementias, but not all dementias are Alzheimer's, which is basically saying that all dementia need not have to be Alzheimer's, all Alzheimer's need not have to be dementia. Dementia has something which is more common because it has 4 diseases underneath it. You can never get to know what is happening under the research which everybody is involved in dementia. That's this factor called as amyloid beta factor is basically affecting everything. It's basically affecting every part of your brain in order to give out this spurious disease called as Alzheimer's. So now, an amylogenic or APP processing is which you are supposed to be tackling through machine learning, because every time where there is a neuronal impulse or any kind of a process which you are supposed to be doing, you're not supposed to be saying that okay, beta amyloid plaques are getting formed, something like that, or else it's being affected. Your beta amyloid plaques are being produced at every given point of time, but at the end of the day, what is being affected is your neurons. So now, what's the chemical composition of it? What's the actual flow? And what's the isoform of it? Isoform, which says that what this amyloid beta can turn your cells into. That's where your isolate forms comes into the picture. And your tau protein is one such entity which is basically affecting how your brain is actually simulating and pluripotency for the stem cells to not to grow. So at the end of the day, when it comes to that, I can solve it through a general medicine. What I do is genomic editing. So now I'll show you actually one notebook which I prepared for my research on XG Boost using the genetic data of the Alzheimer's patient. I'll be sharing the data set. I'll be sharing you the notebook. You all can go through that and you can start working with it. Who found DNA? It's still a big question. It's still a big nonsense which scientists are basically doing that. James Watson actually did not invent it, but in Google, if you search something else, it as who discovered DNA and woman, it says Rosalind Franklin. It's still a controversy. Who invented the DNA? Or else who discovered DNA is also a very big. So and this where at the end of the day, MMEG is where your multi-modified junctions are being formed. And at the end of the day, when these break, there are different genetic information which is being shared. So now, let me just say a tau protein comes here and sits down. And now at the end of the day, I'll open the pointer. Now at the end of the day, it's a point mutation which will be affecting it. So now, just say this breaks down, this breaks down, this breaks down. So now at the end of the day, everything is being affected by it. So human chronic gonadotrophin is a uses that surrounding the growing hormone. That means you are basically doing the HCG test when it comes to the pregnancy test which is being done. But at the end of the day, this hormone is going to affect the growth in a factor of hundreds or thousands, based on which your baby's health is being monitored. Also, luteinizing hormone is one such gonadotrophic cell hormones in which fesals have their LH growth, in which way they are affecting the baby's growth also. So now, just imagine all the things which has to be done by an entire body is being directed by a stem cell. So it's a pretty big deal, because when you look at this as one such thing, a stomach has to be done. But how can a stem cell know that? That's where your genetic information comes into the picture, and I'll keep going through this because I want to give you one of this retinal pigment epithelium in which this is affected by how stem cells are doing. We all complain that our eyes doesn't have any sort of stem cell and we are not being affected. Holy fuck, what is wrong with this? I think sorry for it, and I'll be saying you one thing. Sorry for it. Sorry for it. I'll be sharing you one more slide, which not one more slide. I'll be sharing you the same slide. So now, at the end of the day, we actually looked at okay, cornea is not being used at the research, but why are we not utilizing it? So this came into the scientists in Northwestern University, and they started using the left out part of the cells, where I'll show you one thing. Wait, I'll just show it through the paint. So now just imagine this as the eye. Doctors use this part which has the lens and the vision and the pupil, but this part which is being discarded is not being used, and this part is where the retinal pigment epithelium comes into the picture. So what they do is they do not use it for anything, but they just throw it off. So now the stem cells in Northwestern University just use this part and just made the stem cells out, in which they are being produced every day in order to give. So now, why I am saying you this lady, because she is 121 years old. She is currently holds the world record for being the oldest woman. And now, when you look at this, you say that this is going to kill you, but this is making her live. So now, because of her stem cells being tested, she was proven that because of that, her stem cells are getting strong. But how? Because rapamycin is an FDA approved drug which is being injected in any events or something, and they are being used at one given point of time, which is used for slowing the aging. So anybody who wants to just say that I don't want to age very faster can take rapamycin, but with the assistance of a genetic and a genomic engineer and a genetic engineer and a doctor. So autophagy is one such thing where you are not being cleaned or damaged cells, but you're basically turning each cell into a stem cell, then back to any cell that you want. That means you're actually not utilizing any waste cell which is being discarded, but you're basically regenerating it once again. So now, proboscis is one such technique which stem cell scientists developed in order to have an healthy mouse and a sick mouse being affected by one such disease. Now, your proboscis is basically one such technique where the genetic information is getting shared one after the other. So now, this technique is also being very useful in 3D printing of your cells, in which tissue clearing is being deployed in order to give you access to it. I'll be very frank with you folks. This workshop, I had done it for 3 to 4 days in one institution and also in a startup. So now at the end of the day, you're not supposed to ask me, why are you giving us only this content? I'm supposed to be giving you all what I could do as a researcher. Now I'm giving you that. So sorry, folks, if I can't give you a complete knowledge on what I really know, but please do bear with me. So multifiber photometry is one such technique where this tissue clearing is being monitored at the end of the day with the technique of proboscis. So now it's an optical fiber which is being deployed on your brain, and there are photonic receptors which are being used. So now at the end of the day, you're supposed to be using every given light source. It can be coherent and non-coherent source in order to give a command to the brain through a photonic receptor. Thus, at the end of the day, optogenetics play a major role in controlling it. So now why I'm saying you this, because of using the optogenetics, you can also monitor the way your emotions are. This man is Dr. Najib. He is one of the most prolific lecturers for the people who are in the medical field. So now, when he really talks about something called as emotions, we feel that, okay, doctors are not that emotionally connected towards any person, but yet they're emotionally connected towards their own entity of love. That means it can be a wife, it can be a daughter, it can be a son, or any person. So now, this is not genetically affected, this is not being anything, but yet the way you think can be affected through this process of optogenetics. So now, this is one such TED talk by Patty Dabrowski, which says you how your mindset changes when you start drawing your own future. Thus, at the end of the day, this TED Talks actually really gave me a lot of motivation in order to do the research on how stem cells are being affected. And also this TED Talks is basically giving you, this is basically a talk where you have squint eyes being not affected, and she just does one sort of exercise, and at the end of the day, she doesn't have a squint eye. You can just start seeing her. She was once a squint-eyed person. She doesn't have it. So now this guy is in a neurological examination of an unconscious patient. Every time when you look at this kind of a condition, and every time your stem cells is being affected there, but yet because of being unconscious, he can't really produce the good amount of stem cells. So now whether stem cells can be an very effective means of actually having a control of how your cells are going to divide or something, no. At the end of the day, stem cell does its job even if you are conscious or not. So now when you think about, okay, now I have a fracture, but how can I repair? But this guy is a bodybuilder who is being working for quite a while, but now he he is taking a good amount of time to recovery than what I would require, because he has less amount of fat. That means he is not able to produce the stem cell which is required for it. Lastly, at the end of the day, I'm just going to say you one thing. It's very controversial, because now let me just say one thing. Linux bash uses only integer operation, no floating point operation. That at the end of the day, it's going to have less precise value. So now this has to give a different value, and now this has to give a different value. So now when I divide 640 lakh by the 6, it gives me this. But when I multiply, it's giving me this. This being affected as a calculation by one such stem cell. Just imagine there are millions of stem cells which are affecting you. So now, why I'm showing you this picture? Because it's very controversial. She is not affected by anything, but at the end of the day, distal fascia is being affecting her very badly. So now at the end of the day, as an engineers, let's just work hard, contribute for this community, and let's just make a new one. So now also make an hands-on workshop. I'll be giving you the slides, and I'll be giving you the notebook, and I'll be giving it to the volunteers or the moderators here. And I want one of the moderators to take charge of me, and and if you have any doubts, you can contact me through this URLs which I'm providing you. Because at the end of the day, you're not being affected you're not being affected by the way you're thinking or anything, but you might be having a lot of doubts in you. You can clarify me through this short URL link. This is my LinkedIn profile. You can just contact me here, and I'll be sharing you the slides also. And now I'm open for the Q&A. Any doubts? There are 26 people. At least anybody has some doubt or something. Anybody has some doubts? Hey folks, anybody has some doubts? I know it's a very advanced topic that I took it because my research is also on this one, because I don't use Kaggle datasets, but I have been working on Kaggle dataset. I'll be sharing you that notebook, but I can't share you my personal ones. So anybody, any doubts now? Anybody? Good knowledge on what stem cell and genomics can do in ML. Guys, any doubts now? I know it's an affair. I know. Okay. Man, you can ask me questions. So, anybody? Moderators? Moderators, can I end the session? Pavan, somebody?
Thank you, Vishwas, for such an informative and interesting session on the importance of stem cells in our body. I found your approach to explain about the importance of stem cells, the functioning of stem cells, etc., in our body using memes, videos, links, images, diagrams very fascinating. So I would like to thank you, Vishwas, for conducting this session for us.
Yeah, it's my pleasure being here, and also such a wonderful audience didn't ask me any questions. Anybody can ask me any questions. I've given you my LinkedIn URL. I'll be sharing the slides with you. You can ask me anytime. Thank you so much, people.
Yes, thank you all. If you have any doubts, you can ask. I guess no one has any doubts.
Yeah, fine. Thank you so much. And I'll be sharing the notebook and
Thank
the
you, sir.
slides with you. Thank you, Chinchu Sunil.
Chinchu.
Chinchu Sunil. Thank you so much.
Yes, thank you, sir. Thank you all for attending the event.